Namaste children, I am Hari Prasad, your chemistry teacher. Children, today's topic is variation of electron affinity when you go down the group. Children, we all know that electron affinity depends upon two factors. One is atomic radius and another one is what, children? Nuclear charge. Now atomic radius and electron affinity, these two have what relationship? Inverse relationship. And nuclear charge and electron affinity, these two have direct relationship. Children, to understand this electron affinity down the group, right, we'll consider the elements of group 17, that is halogens. So it is fluorine, chlorine, bromine, and what, children? Iodine, right? These are the four elements what we have considered. The configuration is 27, 287, 28, 18, 7, and then 28, 18, 18, and 7. Children, we all know that when you go down the group, the atomic radius is going to what, children? Increase, right? See, observe here. See, nucleus, outermost shell. Fluorine, 2 shells, right? This is fluorine. Chlorine, size is increased. Why? 3 shells. Then bromine, bigger than chlorine because it is having 4 shells. Then the biggest is what, children? Iodine. It has got how many shells? 5 shells. See, fluorine, chlorine, bromine, iodine. So atomic radius is what? Increasing. So as the atomic radius increases, the electron affinity will what, children? Decrease, right? Now, fluorine, 9 protons, right? And then chlorine, 17. So bromine, 35. So that is, the nuclear charge is also what, children? Increasing. As the nuclear charge increases, the electron affinity also increases. Now children, we will see the values and we will discuss about this one. Children, before writing the values, again I am telling you, these values I am writing just to make you understand. No need to remember the values. And the unit for electron affinity is kilojoule per mole or electron volt. And the values of electron affinity is negative because energy is released, right? If it was ionization potential, energy is absorbed. For electron affinity values, there are cases where the values are what, children? Positive also, which you are going to learn in higher classes. Now children, electron affinity of fluorine, in this case it is electron volts, minus 3.60. More negative means more energy is liberated. So chlorine is minus 3.80. Bromine is minus 3.50. Then iodine is minus 3.20. Huh, children? Oh, maybe I think this should come here and this should come here, right? No, it's correct only. If anybody asks you, out of these 4 elements, which is having the lowest electron affinity, your answer is iodine. Who is having a highest electron affinity? It is chlorine. Children, what we'll do is that we will discuss about this one later. Assume that this is not there. If you exclude this, what is happening to the values of electron affinity when you go down the group? The electron affinity values are continuously what, children? Decreasing, right? Sir, atomic radius increases, fine. Electron affinity decreases. Yes, it is decreasing. Correct. No problem with this one. But along with atomic radius, nuclear charge is also increasing, no? People say that as the nuclear charge increases, electron affinity should increase, but it is not increasing, it is decreasing. So, out of atomic radius and nuclear charge, who is dominating? Atomic radius. Now the question arises, why atomic radius dominates over nuclear charge when you go down the group? Children, observe very carefully. This is fluorine, which has got 2 shells, and this is chlorine, which has got how many shells? 3 shells. And this is bromine, which has got how many shells? 4 shells. Children, we all know that, right? Out of the 3 examples what I have taken, the biggest atom is which one, children? Bromine. Now what happens is that there is one effect which I have already discussed. What is that? Shielding effect. What is shielding effect? Shielding effect is nothing but the decrease in the force of attraction between the nucleus and the outermost electron by the electrons of what shell? Inner shells. Now, between the nucleus and the outermost electron, how many shells are there in case of fluorine? One shell. One shell is acting as a screen between these two. In case of chlorine, right? Chlorine, between nucleus and outermost electron, how many people are acting as a screen between this and this? 2 people. That is, the number of screens here it was 1. Now here it has become 2. Now in case of bromine, between nucleus and outermost electron, how many screens are there? 1, 2, 3. So 3 screens are there between nucleus and outermost electron. So the effect caused by these electron shells, right? That is, these shells containing electrons, we call it as what? Screening effect. So because of this screening effect, though there is a increase in the nuclear charge, it is not able to accept the electron most readily. I repeat, the size of the atom is increasing, the distance between the nucleus and the outermost electron increases, right? The force of attraction will decrease. So whatever may be the increase in the nuclear charge, that is not affecting the values of what? Electron affinity. Because of what? Screening effect. So conclusion from this one is atomic radius dominates over nuclear charge because of screening effect. Right, children? Now let us come to this one. Sir, actually there is some problem, I believe, because when you compare fluorine and chlorine, chlorine is bigger atom, right? And when chlorine is bigger atom, these values clearly suggest that chlorine is accepting the electron most readily and it is releasing more energy when compared to fluorine. Actually, it should have been other way, no? What is that? The electron affinity of chlorine should have been less than the electron affinity of what? Fluorine. Because chlorine is bigger and fluorine is smaller. See, bigger size, electron affinity is less. But here's some problem actually. Why the electron affinity of chlorine is more when compared to the electron affinity of fluorine? Actually, it should have been what? Less. So why it is more, we'll discuss in the next video. So conclusion is, when you go down the group, right, the electron affinity is going to what, children? Decrease because of increase in what, children? Atomic radius. And the group of elements which is having a maximum electron affinity is group 17. Those who are having a more electron affinity or high electron affinity, they are also electron negative in nature, which we are going to discuss in the coming videos. Okay, children, I hope you have understood whatever I have done today. Thank you, children. Namaste, everybody.